Okay, ladies and gents, so today we're going to be carrying out a challenge, and that challenge involves computing and dance.
Here's the hook to get your students interested.
As part of this challenge, you're going to look at a dance video, and within that dance video you're going to pull out some key frames within that dance sequence. Then what you're going to do is create your own dance sequences, and you're going to put them together to create your own routine, which you will then use a programming language using some programming skills in order to recreate that routine. So what I'd like you to think about is what sort of dance videos do you enjoy watching, and what sort of sequences and moves go on in those dance videos?
They own the challenge and should be engaged and motivated.
Do you guys see that group on Britain's Got Talent a few years ago called Diversity?
Oh,
Yeah,
they were really good. I think the reason why they were so good was because they included the classic dance moves that you get in a street dance group, like flips and things, but then they gave it their own twist.
I really like Pharrell Williams' Happy, as it describes the mood, and there's loads of different people all involved doing different things.
So all like their own dance, kind of like expressing that they're all happy doing like what they love to do.
What I found with it is that he does the same move over and over again. Then in the second music video, he did the same move just with a different variation.
I don't really like the song, but the video is just good. Where you just use your hands and you can use your hips as well.
Yeah, it's the same with the Macarena because you're rotating your hands and then
And why it's not a lot of effort doing it, is it?
Yeah, everyone recognises those songs because when they hear the chorus, they'll automatically go like, what? Like that.
Okay, ladies and gents, so we had some fantastic discussions go around the different tables. It's really interesting to hear what you were talking about in terms of the different moves and the different videos you've seen and how it all fits together. It was absolutely fantastic. So when we're thinking about these moves that go together to make a routine, what do we call it when we have them in a particular order, in the correct order? What sort of term do we give that?
The teacher is drawing a parallel between the hook and computational thinking, between a dance routine and algorithms and algorithmic thinking.
Jack?
Isn't it an algorithm where you've got, well, in computing it's a collection of commands in order and there can be some repeats, but you could also use that with dance moves.
Yeah, that's absolutely right, Jack. Could you just expand on that a little bit and tell me how that would work in terms of a dance routine though?
Well, with dance, you can have a certain amount of dance moves, which will be the commands, and you could put them in order and you could have them repeating a bit.
Right, excellent. So what Jack's kind of described there is we've got a set of instructions that are in a correct order. We can use extra skills such as repeats to make an algorithm so that when we run it, it will look like a routine.
It is important to correct and reinforce vocabulary. Here we can see the students' use of the term commands corrected to instructions.
Okay, so what are we looking at?
Okay, so that's the start position. Yeah, and then they move the leg round so it's getting into a straight position, which flows nicely into the next move. And then from the clap it goes. So should that be like one move? So you go up top and then to a climb and then to a handstand. So it's like sort of a bar. Yeah.
You can see evidence of computational thinking taking place, of students carrying out decomposition, generalization, and evaluation, as well as, of course, algorithmic thinking. These concepts can be drawn out during the plenary, so that students make the link between the concepts and what they have been doing.
No, you do it above.
No, but you could just have bending, but bending really fast, sort of thing.
For the moment, the teacher is collecting evidence for formative assessment.
So if each one of these is an instruction, how many instructions are going to make your algorithm together? How many do we have?
2, 3, 4, 5,
And then would be like the move.
6.
Okay, so you're going to have the 6.
We've still got this guy up here.
Okay.
So far.
Down there.
So are there any sections there that you could repeat? Are there any part of this that you could repeat so when you program it, you could make it efficient and reuse some of your parts?
Could repeat
Right now,
over here somewhere.
People who know all about that. What about you right now?
Okay, ladies and gents, so just bring you back together. So what we're going to have a look at now is we're going to have a look at how we can create procedures in Scratch. So what you've all been doing is creating your separate frames or your separate moves of your dance sequence, your dance routine. As you can see over here on the board, we've got a character here, a sprite here that's going to do a very kind of simple breakdance for us. So we've already got a sequence of instructions, okay, which we know as an algorithm, and they're wrapped around an iterative loop. So they're wrapped around a repeat that's going to do those instructions 5 times. So if I just execute those commands, we will see the breakdancer carrying out a simple set of 3 moves to make a very, very simple sequence. Okay? This may not be the whole routine, this may just be part of the routine. Okay? Now what we're going to do is we're going to kind of package up those sets of instructions that we've got on the board there into what's called a subroutine or a procedure. And this allows us to have what we call procedure abstraction, where we know that set of moves now, so we don't need to revisit those moves. We know as a dancer, when I'm asked to do the breakdance, I do those 3 moves. Okay? So what I'm going to do is in the purple section here, where it says more blocks, I'm going to make a new block. I'm just going to call this breakdance. Okay? And I'm just going to move this over here. So what I've got now is I've made my own kind of procedure, but it's got nothing inside it. So running that procedure would effectively execute nothing, so we wouldn't see a result. So what I'm going to do is I'm going to take these instructions and we're going to put them inside our procedure, or sometimes known as a subroutine as well. Okay? So we've got our algorithm inside that procedure. As you can see from that algorithm we've got on the board at the top right there, is we've got 3 sets of blocks that kind of repeats. We've got kind of what we know as pattern identification going on there, because you can see there's a command, and then there's a wait command, and there's another command and a wait command. So we're reusing our skills to know that we can repeat that purple and orange set of blocks. Okay? Now at the moment, if I run that, execute that program, it's not going to provide the output we're expecting, because at the moment we're not calling that procedure. So what I need to do is grab my procedure call here, put that inside my repeat block, and then we can execute that procedure. So when we get in the repeat loop, our iteration there, it will run breakdance, which you can see over on the right hand side will then execute that code. And as we said earlier, what we could then do is have lots of separate procedures in order to build up that routine. Okay? So if I execute this now, we'll be able to see that we can still get the same output, but we've packaged it nicely, and we're hiding that complexity of those 3 separate moves by just giving it one name. So when we've learnt those 3 moves, we understand what that one name is. So that's how procedures work. You can see that we've got the algorithm, we've got the pattern identification in there by identifying areas that repeat, reusing our skills as well.
The teacher is exemplifying the computational thinking concept of procedural abstraction through sequences and procedures.
Okay, so we're now going to take your dance moves and we're going to try and program those using procedures.
Make sure that the floor is clean and the area is safe before students begin choreographing their dance routines. And here's a tip that we haven't actually done here. After students have imported their images, ask them to cut round them so that they can import a background that creates a better atmosphere for their dance routine.
That's about right. Oh,
That's wrong.
So
And for this writer.
Students complete the challenge through paired programming.
Oh yeah, add a weight so that it doesn't just go through the motion. That's in control.
Wait. How many seconds?
0.1?
0.2, because otherwise it'll be a bit quick.
0.15?
Okay, 1.5. Meet in the middle.
And go through that.
Play. Yeah, that's much better.
Okay, so you've got the frames in the right order, you've got a nice algorithm, nice sequence. So what can we do now to use the procedure? Okay, do you want to talk me through that, Dance? How does that work? Okay, Okay.
And then create, we'll put that there, and then we can reuse dance whenever we need it again.
And what does that achieve? Why would you want to do that?
I guess it saves space and it's not all in one huge long line of.
And then you could, like, if you wanted to do that, like in different places,
So let's just check that that's what.
then you could, rather than having lots of frame 1, frame 2, frame 3.
Oh, it's the right time though.
You guys, how are we doing?
We're still trying to get the time exactly right for that.
So James, over here, what would happen if we didn't have these weight commands?
Yeah, two seconds maybe.
Okay. So how would that look
Hold on. If we're
when you look at it?
It is important to provide formative feedback to draw out computational thinking and encourage independence and resilience when bug fixing.
they're up too quickly. We've actually done that too.
Yeah, 2 seconds.
Do space.
Evaluation, the process of ensuring that a solution is a good one and that it is fit for purpose, is a computational thinking concept. So you can round off the challenge by asking students to evaluate their animation.
Okay, so what's so good about your work that you've done so
At
far?
the moment, we're customising it, so at the end, if you press the spacebar, you can trigger it to play again, or as many times as you want it to.
So do you want to just run your video and your animation for it at the same time for me? We'll have a look.
Try and get it as quickly as possible.
How's that looking? It's like the right sort of sequence there, doesn't it? Yeah, it's in the right order.
Bit ahead though.
Yeah, it's a little bit of timing, a little tiny bit that can be tweaked. So that's a little bit of sort of debugging,
Yeah, I
see
think
if you
it's
can adjust
between
the...
the 2 frames at the beginning that we need to add. Should we change that to 3 seconds and see how that looks?
Try to.
Between 5 or 6 or 6 or 7.